Welcome to Calculus in the PM. Mr. Shindalka here. We took a look the other day at the derivatives of the two basic trig functions, cos and sine. Do you guys remember how everything trig function-wise could be broken down into sines and coses? Tangent is the ratio of sine over the cosine function, etc. Cosecant and secant and stuff are inverses. Okay, you don't have to worry too much. Anyways, cotangent, everything can be broken down into sines and cosines. What's that mean? Well, it means that as long as we have these results, we can do derivatives of sine and cosine function. We can use manipulation methods to figure out for the other ones. We're not going to, we're just going to memorize the results. I'm just saying it isn't witchcraft, they come from something. Now what you guys have to memorize, and I've mentioned this before, is these two things. Have these memorized. If the function is sine of x, the derivative is cos of x. Again, derivative of sine of x is. The derivative of cosine of x is negative sine of x. Good. I don't know this stuff, I'm just reading it. Yeah, but the more it goes through your head, the better. Because although on my chapter test for regular calculus 30, you'll have that. Okay? And for regular calculus 30, it's not a big deal. But honestly, you'll do this enough that you'll have it in your head anyways. But you won't be getting any formula sheets on the AP exam. So that's why I keep going over these things. Now, some extra stuff. This is page 4 on your handle, right? Okay, that's where we left off. I'm not worried about how we do this, but we know the quotient rule and stuff like this. As I said, things can be broken down into sines and cosines. But really what you need to do is know this. The derivative of tangent is secant squared of x. Now, then, what about the remaining functions? Well, this is all listed here. Okay? This is what you need to commit to memory, okay? Eventually. Now, I don't say go tonight and try to memorize these. For this chapter test, I'll give you a function or a formula sheet. So don't worry that way. It's not immediate, but your goal is to do enough of these that you definitely, the sine and cosine you'll definitely have. The other ones, you might have to have a little bit of memory help, but well, you'll do this. Now, as I look through this, just take a look at this though. Okay. I think you already know these two, correct? Like, more or less, you're familiar with these. Okay, that's easy. What do you notice about all of the co-identities, cosine, cotangent, and cosecant? The derivatives, what are the answers always? Negatives, right? Just saying. Because when I did this in university, and I was like, I just do this at the top of the page, I just like, if the function is sine of x, I just do, and then if this is f prime, this, I just whip this off like real quickly. I'm not going to do the whole thing, but I do this at the start of the test and say cos of x, tan of x, and I just write these all down here real fast. And you guys have done similar things, I'm sure, in tests, so I don't forget. Okay, that kind of thing. Well, the first thing I do then is all the co-identities, I put a negative sign in front of them, right? Bang, bang, bang. Then, really and truly, you notice how sines and cosines, you can see how they're related. The sine function gives you the cosine function. Cosine gives you the negative sine function. Well, take a look and tell me with the relationship. Tan of x gives you secant squared x. Cotan of x, hey, if you know this secant squared thing, what's the connection between secant squared and cosecant squared? Oh, yeah. It's just like, take the same thing but call it cosecant squared of x, right? Does that mean? So if you have this one memorized, I don't think it's a big stretch to know this, right? Likewise, when you do the derivative of secant of x, you get a product out of this. It's secant x times tan of x. Okay? The co-identity, of course, is negative, but notice this. Instead of secant x, you got cosecant x. Instead of tan of x, you got cotangent x. You see the pattern there? So, whatever you have, this is a memory aid. It's just the way the calculus works out. Sine of x, it came up with cosine. You just switch the cos in this You know what I mean? Either take off or insert the cosine, sine. Secant, cosecant square. Secant tan x, cosecant, cotangent of x. The positives and negatives, you know where they fit in? Really, I'd say you really only have to have 1, 2, 3 committed to memory, and then the others follow from that. Do you guys sort of see what I'm saying? The negative signs on the co-identities. As long as you have this, you know that the cotangent derivative is cosecant. As long as you have this, you know that secant becomes cosecant, cotangent, when you're talking the derivatives. I'm just trying to make your memory, memorize as little as possible, just sort of know. Well, this one, you kind of have to memorize these. I'd say you have to make an effort to memorize these last 4. The first 2, I think you'll just know because you've done them enough. The other 4, okay. Now, all you have to do is try these out. Now, I said in the assignment to do the circled ones the first day. I'm not even doing an example here, so let's do one together here. And, well, let's just do number 2 real quickly from the assignment then, and then we should be good. And then we'll take a look at something else here. So number 2 was, if the function is y equals 2 sine of x. We could do this as an example on the side of the page, whatever, you don't have to do it later then. 2 sine of x minus 10. Then all you have to do is apply your new rule. The new rule, though, okay, so we got this. Minus tan of x. I don't know if you have this memorized, but it's secant square of x. It's just that simple for this. Minus secant square of x. So it's just applying the new rules. It's getting familiar with them more than anything. Okay, and that's that. It's done.
So the derivative of y is 2 cos x minus 2 secant.
Minus secant squared of x. That's it. Now, do I have something else on there on another page with review?
Yeah.
Say? Good. Well, let's see what you guys can tell me about this. Evaluate using the easiest method possible. Now, I include this because I don't want you forgetting stuff from a little ways back. Huh? This is a limit question. But there's a couple ways we could evaluate this. Any ideas? Derivative of 3? I think you're at it, but not. What?
I was going to just put like, because it's x minus 3, so then you could do root of x minus root of 3, and then root of x plus 3.
Oh yeah. Make it a complete, or a difference of squares, and you could do it that way. And I like what Paul of Deep said first, though, too. You're right, and you could do it. This one isn't that tough to do algebraically. And you'd use that. But can you recognize that this is the definition of a derivative when the function is root x, evaluated at 3, too? So that's the other way of doing it. Let's see if you get the same answer either way. I said the easiest method possible. I don't know. I actually think derivatives are easier, but if you multiply top and bottom, I'm going to go with both methods here, and we'll just compare it. As you mentioned. Okay, so this is the one method you mentioned, right? What do we get on the top? Don't multiply out the bottom. Top you got x minus 3, right? All over x minus 3 from before, root x plus 3. Hey, we can do some cancellation, right? Can I evaluate that limit right now?
Yes.
Yeah, I sure can. I've got root 3 plus root 3 on the denominator. 2 root 3. let's see if we try the, recognizing that this is essentially the definition, one variation of the definition of a derivative at a particular value, right? The function must be root x, because then when you plug x equals 3 into root x. Okay, you get the second one. Okay. So let's just see if it works the other way. So if f of x is equal to, I'm not going to write it as root of x, I'm going to write it as x to the half. Oh, that's messed up here. X to the half. So what's the derivative then? Half x. You are always kidding. Okay, right? Subtracting 1. And we want to evaluate this at the number 3. So, 1, 2, what does that root, or I mean x to the negative 1/2 mean? It means put it downtown, right? Root underneath, and that's root 3 with the 3 plugged in. Same answer. Now, which is actually less work? It depends. This one you could have done either way. I gave a simple enough one that you could have quickly done it with algebraic methods, right? Okay, 2 questions, Sarah and then Emma. Yep.
Where did x to the 1/2 come from? I was going to ask that.
Oh, I'm just saying, do you recognize from this expression here, the original expression, that this must be the derivative for this function, which is x to the 1/2. I just can't do calculus with this notation very easily. Is that what you mean? Like where'd this come from? Yeah. Just rewriting root x as x to the half. And I know that this means evaluate at 3. Emma.
That was a similar question. I just wasn't sure you recognized right away that was.
Now, this is a simple enough one, like I said, you could have evaluated it either way. You have something with natural logs later on and stuff, it'd be way easier to do the derivative method. So you have 2 ways of doing this. How about this next one, though? What does this one look like? Do you want to do that as a limit? I'd say try not. But what does it look like? What's the function? Now, I gave this, what does it look like? It looks like a definition of a derivative. Evaluate it at what point this time? Yeah. This is like that f of a plus h, right? Minus f of a notation. So this is evaluated at pi quarters. The h is that little 0. You guys recognize that as the definition of the derivative? It's the slope formula with the limit. Okay, so the shortest way possible is not doing this limit. That'd be a nightmare. So I'm going to instead say it's like the function is the I can't write. Cosecant. Oh, you know what? Yep, that's screwed up on it. Wait for that to disappear. Equal to cosecant of x. My derivative. Hey, I just learned this one. What is my derivative?
Negative.
It's going to be negative for sure. Yeah. Cosecant. Cotangent. That's just from what we just listed, that list of derivatives. You'd have to look that up right now until you get that in your head. Okay? Now, we want to evaluate it though at pi quarters. I doubt that anyone has this one memorized, cosecant of pi quarters. Or the cotangent, pi quarters. So we're going to have some methods here. Do not memorize The only thing you need to memorize is two triangles. Now this one's not being used, but have this memorized. If this is pi 6, 30 degrees in old school speak, pi thirds. This is 1, 2, radical 3, right? You guys know what I'm talking about there. Pi quarters, this one, right? 45 degrees. I don't like saying 45 degrees, but pi quarters. What's the triangles? You can't read my pi quarters, but I'm just put it in like this. 1, 1, radical 2, right? Or I had to say radical 2 and I write down something else. Anyway. Okay. Now, we can get back to the problem here. We're going to use this triangle here, 1, 1, radical 2 triangle. Cosecant is the reciprocal of which function? I've heard both sine and cos. Sine, yeah, it is. So that you will be expected to remember for sure too. Okay. So I'm going to just do this as an aside. Cosecant of pi quarters is the same as the reciprocal of sine pi quarters, right? Now in this particular one, even if you had mistakenly put down cosine, you still would have gotten the right answer, wouldn't you? Because what is the sine of pi quarters? 1 over root 2, right? I don't care about root 2 over 2. Whatever. If it needs it at the end, if it's multiple choice, fine. Okay. You guys follow what I'm saying here? 1 over 1. Now, do you see why I'm writing it as 1 over root 2? Because what's 1 out? 1 over 1 over root 2.
Root 2.
It's just plain old root 2. Okay, I heard a what? That's cool. Talk to me. Talk to the man. No? Papa Joe? You're going to wait on this, or come see me after that if you're not. Cotangent is the tangent function. But you know what? This one is a nice one. Tangent function, I guess if on the video you can't see me flipping my hands, reciprocal. Okay. Opposite over adjacent is 1, right? So the cotangent reciprocal is also 1, right? You guys follow me on that? So, this is your answer. Negative root 2, really. I'll put the 1 down just so you know we considered it. You guys follow that? Yeah? Okay. Never, ever, if you see a question, and there's a good chance you will see a question like this, with a limit like this, and you're like, just take a look. Sometimes your limits will be really the definition of the derivative in some form. Just say, hey, it's easier to do the derivative to answer this question. Okay? That's the end goal for this.